Hello everyone, Duffy here, and today I want to show you a little math problem that I found quite interesting. So, without further ado, let's begin. Now, before I give you the solution and the explanation, this is going to be my full solution to this question. So screenshot it or whatever you want. I don't care. But the explanation is going to start in 5, 4, 3, 2, 1. Okay, this is the question here. Find the value of x that satisfies this following equation. And we can see that the equation is 7 to the power of x minus 1 plus 1 over 7 minus 6 over 7 to the power of x is equal to 0. And let's first simplify this as following. 7 to the power of x, 7 to the power of x times 1 over 7 plus 1 over 7 minus 6 over 7 to the power of x is equal to 0. And we could define 7 to the power of x is equal to m, let's say. And we could simply substitute that into the equation here. So m over 7, because 7 is m, because this is m times 1 over 7 is simply m over 7 plus 1 over 7 minus 6 over m is equal to 0. And this is where the fun part happens. We need to get rid of these denominators. How do we get rid of these denominators? Well, simple. We just times both sides by the denominator. So let's say we want to get rid of m, that means times m over here times m over here. And the result of that is m times m over 7, like so, plus 1 over 7 minus 6 over m is equal to m times 0, like so. And we could simply times it, so m times m is m squared over 7 plus m times 1 over 7, simply m over 7, and m times negative 6 over m is simply negative 6, like so. Is equal to m times 0 is still 0, like so. And now we need to get rid of these 7's. So we need to times both sides by 7. 7 and m squared over 7 plus m over 7 minus 6 is equal to 7 times 0. And we could simply times this out. So that is m squared plus m. Then 7 times negative 6 is equal to negative 42. That is equal to still 0. 7 times 0 is still 0. And now this is a quadratic. Now we could find the value of this quadratic by using the quadratic formula, but we don't need to. We could just simply factor this out. m. Sorry. So to factor this out, we need to find two numbers that when added together is equal to 1, and when they are multiplied by each other, the result is negative 42, and the only solution for that is negative 6 and positive 7. So we could simply write this as as minus 6, yeah, like so, plus 7, like so. That means the solution, there are two. M1 is equal to positive 6, and M2 is equal to negative 7. And we go back to this original claim that 7 to the power of x is equal to m. That means that the two possible solutions are 7 to the power of x is equal to 6, and 7 to the power of x is equal to negative 7. But this specific equation does not exist. What I mean by that is that it's impossible. Let's say a to the power of b is equal to c. If a is real, then c must be positive. Pause. But this a, if cannot be an imaginary number, right? If c is positive, then a cannot be imaginary. A has to be real, right? And since a in this equation is 7, and that is a real number, that means the c here cannot be a negative. Cannot. So the only solution to this is 7 to the power of x is equal to 6. Then the question asks for x here. So what is x? We could simply use the function log. What is log, you might ask? Well, it is simply a function to find any exponent of any number given the output. Let's say 3 to the power of 2 is equal to 9, right? That means that 2 is equal to the root number here, 3, log the output number, 9. That means that for the equation 7x is equal to 6, that means what we're trying to find is x. That means that the log function is the root number, 7, the base number I mean, and log the output, 6. There you go. That's your answer. X is equal to 7 log 6. Done.